Hello and welcome back to my channel. Today in this video we are going to discuss the questions of exercise 1D from Selina Concise Mathematics, class 9th ICSE. So here is the question number 1. Simplify root 18 over 5 root 18, 3 root 72 and minus 2 root 162. And we need to simplify it, and whenever we get a composite number, we are going to do the prime factorization of it, and we will see what can be outside of the square root. So 18 is 2 into 3 into 3, 9 2s are 18, so 2 into 3 into 3, and here it is 18, again 2 into 3 into 3, and then here it is 72, so 9 8s are 72, 8 is 2 into 2 into 2, and 3 into 3 is 9, and similarly for 162 it is going to be 3 into 3 raised to the 2 into 3 raised to the power 2, and we do the prime factorization in this way. 2, then 2 8s are 16, 2 1s are 2, then 3 2s are 6, 3 9s are 27, then 3, then 9, then 3 3 and then 1. So 3 4 times 3 to the power 4 into 2. And now since it is a square root, so pair will come out, so it is 3 root 2. Again here it is 3 into root 2, but 5 is there, so 3 5s are 15. Here it is 2 1 2 here and 1 3 here will come out, so 2 3s are 6, 6 3s are 18, and similarly there are 4 3, so 3 2 3 will come out, that is 9 will come out, and 9 2s are 18, so we got 18 root 2. Then we can cancel these two because they are same but the signs are different, and at the last we got 3 root 2 upon root 15 of 15 root 2, root 2 cancel, 3 by 15, that is 1 by 5. Now let's do the second question. Simplify this. There is a division, and we know a divided by b is simply like a into 1 upon b, the reciprocal of the another number b. So first thing we will do like division, and then this will go in numerator as this, and this will come in the denominator. And now we can see this thing can be seen as a and minus b, and here a plus b. So it become, by the identity a plus b, a minus b, we have a square minus b square. So we got this as this square minus y square, and this square means the square root and square root be cancelled, and we get x square plus y square, and here it is y square. And denominator also we can see it is x minus this, and this can be written as x plus root x square minus y square. So again it is also a plus b, a minus b, that is x square minus root this square. So if we cancel this and multiply by minus, we'll get minus plus, and we got this, and we can see y square cancel, x square cancel, and lastly we got x square over y square. That's the answer of it. And now let's do the third question. We have to evaluate this correct to one decimal place, the expression this, if if root 5 is 2.2 and root 10 is 3.2. So these two values are given just to simplify this value. And now since we have the denominator, and we know the rationalization is required when actually we do the rationalization so that we can easy our calculation. And if the denominator is root 3, for example, only root 3, and we know that root 3 is 1.7, then it would be difficult to divide by 1.7. So we do the rationalization of it by root 3 into root 3, and then we will get root 3 in the numerator, and denominator it would be only 3, and then we can divide 1 by 7 upon 3 easier than dividing by 1.7. So we will first of all factorize this, and we could have taken root 20 also as root 4 into 5, that is 2 root 5, but it's fine because it will not make any difference. So now in order to rationalize the denominator, first of all you will find what is the rationalizing factor, that is root 20 plus root 10, then we divide and multiply both, and then we get 5 times root 20 plus root 10 upon 20 minus 10, because it is a minus b, a plus b, a square minus b square, root 20 square is 20 minus root 10 square is 10. So 20 minus 10 is 10, so it is got cancelled 1 by 2, and the denominator again it is 20, so 2 will come out, 2 root 5 plus root 10. Now we have root 5 value as 2.2, so we substitute this value. Root 10 is given 3.2, and that's the simple calculation, 2 into 2.2, and then we add them and then divide by 2, and see, it is easier, very easy to calculate, rather than if you put this here directly, 5 upon 2 root 5 minus root 10. It would be difficult if you simply put root 5 as 2.2 and root 10 as 3.2, then it would be difficult. So that's why we should do the rationalization, then we should practice this. Okay, next is fourth one. If x is given root 3 minus root 2, find the value of first one, x plus 1 upon x. So whenever we have an irrational number, first of all we need to find all the possible values they are including. Like here x is included, 1 upon x is included. So first of all we'll solve 1 upon x. 1 upon x means 1 upon root 3 minus root 2. And again we got the denominator irrational, so we'll rationalize the denominator by rationalizing factor root 3 plus 2, multiplying by these two, and we will get the numerator as root 3 plus root 2 and denominator as 3 minus 2. So we got root 3 plus root 2. So once we have x and 1 by x, it is always going to be easier because we have root 3 minus root 2 and root 3 plus root 2. These two like terms, opposite sign, so it is got cancelled. Root 3 plus root 3 is 2 times root 3. Second part is if you have x square plus 1 upon x square, so there is this identity. We will use this identity. This identity comes from x plus 1 upon x whole square, the a plus b whole square formula. This is a square x square plus b square 1 upon x square plus 2 times x into 1 upon x, and x will be cancelled, and we will get this x plus 1 upon x whole square equals x square plus 1 upon x square plus 2. So if we'll transfer this thing to the other side, it would become minus 2. That's where we got this identity. And now we have x plus 1 upon x from the previous part, and 2 is already there. So 2 root 3 square is 2 into 2 root 3 into root 3, and that 2 2s are 4, 4 3s are 12. So 12 minus 10, and it is 10. In the third part, it is x cube plus 1 upon x cube. Again we can use this identity. It is derived by a plus b whole cube. It is a cube plus b cube plus 3 times ab times a plus b, and if we get from here a cube plus b cube, we will get this as a plus b whole cube, and sending all the things to the other side, we will get this. And since here the b value is 1 by x, so x into 1 by x would be 1. That's why we get this identity, and we have all these values. These two values are same, 2 root 3, and we can substitute it here, and we can do the simple calculation to get the last answer, that is 18 root 3. And the fourth one again, x cube plus 1 upon x cube minus 3 times x square plus 1 upon x square and x plus 1 upon x. So we have all these values from the previous parts, so we can simply replace these values and we'll get the answer. Now the next part is the fourth question. This is fourth question. State true or false. Negative of an irrational number is irrational. Of course it is true, because if I have proved it here, if x is an irrational number, then minus x is also an irrational number. That is what we need to prove. So if possible, let's assume minus x be a rational number. So if minus x is a rational number, the negative of a rational number is again also a rational number. So it means minus of minus x, minus minus cancel, you got x as a rational number. But it is given that x is an irrational number, which is a contradiction. Hence minus x has to be irrational, because our assumption is wrong. So therefore negative of an irrational number is always irrational. The product of a non-zero rational number and an irrational number, the non-zero rational number and irrational number is a rational number. It is wrong, because we can take 3 as a rational number and root 3 as an irrational number. If we multiply, we will get 3 root 3, which is of course non-terminating, non-repeating, hence it is going to be irrational number. So it's not a rational number, hence it is false. Question number 5th, 6th, 7th, it is, just a minute, 3rd, 4th, it is 5th, and it is 6th question, it is 7th. Yeah, so in the 6th, 7th, 8th questions, we need to draw a line segment of length √5. In these type of questions, we draw a line segment, mark the points 0, 1, 2, 3, and so on, and then we will write 5 as a sum of two square number. Like here I have written 5 as 4 plus 1. So 4 plus 1 can be written as 2 square plus 1 square. And if we take this, then we can see by Pythagoras theorem, if it is a right angle triangle and it is 2, it is 1, by Pythagoras theorem, this is going to be 2 square plus 1 square, which is going to be √5. So that's what we are going to implement. We'll start from 0, and we will measure two distance on the x-axis, and we'll draw a perpendicular or at 2 by this method, and then we will mark one distance on this perpendicular line. Let's say this is one distance, and then it is by Pythagoras theorem, this hypotenuse would be the √5. And if you want to represent on the number line, so we will take this as a center and this as a radius. We'll mark the arc, and we will get this here, and this point will represent it by √5. So I hope it is clear. In the same way, if we have √3, 3 can be written as 2 plus 1, and 2 we can write √2 square, because 2 and √2 got cancel and become 2 only. So √2 square plus 1. So first of all, we have to denote √2. And if we take this distance, let's say 0, and it is 1, and this is also 1, so this distance is √2 by Pythagoras theorem. So if we have √2 here and we add 1, then this distance would be √3. So by the same method, you will get this as √3. For √8, it is 4 plus 4. So the two sides has to be same, that is 2, 2, and then this hypotenuse would be √8 by Pythagoras theorem. Then here comes the 9th one. Show that this equals 52 by 11. So again, we have denominators as the irrational numbers. So first of all, we will find if we can get the denominator as the rationalizing factor of each other. And we can see 4 plus √5 and 4 minus √5, rationalizing factor of each other. 5 plus √3 and 5 minus √3, again rationalizing factor of each other. So we will collect them together, and it is plus everywhere. So we will write these two together, first and third term, and second and fourth term together. Now we don't have to rationalize the denominator, because if you multiply, we'll solve the fraction. It is like 2 by 3 plus 1 by 5. Then we multiply the denominator, and then we do the cross multiplication. By simply this method, we will get the denominator as 4 plus √5, 4 minus √5, and here it is 4 minus √5 into 4 minus √5. This is going to be whole square, and 4 plus √5 into 4 plus √5 whole square is here. And similarly, in this case, we have denominator as, now we got a rational number, because it is a plus b, a minus b is a square minus b square, 4 square is 16, √5 square is 5, and here 5 square is 25, √3 square is 3. So denominator become 22 here, and we of course open the bracket by a minus b whole square, a plus b whole square. We will get this identity. We cancel these two, and here these two, and then 16 plus 5, 21, again 21, 42, and here 10 plus 10, 20. So we can simplify 10 by 11, then we got 10 by 11, and denominator same, so it is 52 by 11. Or we can, like the question could have been asked, like show that this is going to be 8 over 11 also. Then also we are going to do that in the same way. Yeah, so it is 10th question. Show that this cube equals 52 if x equals 2 plus √3. So in these type of questions, again, if we know this identity we have used once. If we know this identity, so what we are going to calculate, if it is 1 upon x, so first thing we will calculate 1 upon x. 1 upon x means the denominator is irrational number. We will rationalize the denominator, we will get this, and then it become very easy, because we have only the numerator, x plus 1 upon x, x is 2 plus √3, 1 upon x is 2 minus √3, these two got cancelled. Similarly here also it got cancelled, and you got 2 plus 2 4 cube minus 3 times 2 plus 2 4, and then 64 minus 12 is 52, and hence proved. And second one, now we need to prove that x square plus 1 upon x square is 34 when x equals 3 plus 2 root 2. Again 1 upon x, so we need to use this identity first of all. Otherwise also we can calculate like in this way. If it is x, then we can calculate x square and 1 upon x square, then add it, then also we'll get 34 in case we don't remember the identity. So as we can see, we have used this identity, so I will use in this way. And then 1 upon x rationalized, we got 3 minus 2 root 2, and then we can see they are very similar. So 3 plus 2 root 2 and 3 minus 2 root 2, these two got cancelled, we got 6. So once we got x plus 1 upon x, we can directly calculate x square plus 1 upon x square. The last part is 3 root 2 minus 2 root 3 upon 3 root 2 plus 2 root 3 plus this. So we can see that they are not rationalizing factor of each other, the denominator of these two fractions. So we will rationalize it individually. So for rationalizing the first term, we have multiplied and divided by its rationalizing factor. Similarly here, and then the denominator becomes the square a plus b, a minus b, a square, that is 3 root 2 square. 3 root 2 square means 9 into 2. 3 square is 9, root 2 square is 9, 2, that is 18. Similarly 2 root 3 square is 12. And then what we are going to do, when we will do the it is done. When we multiply these two, we get 3 root 2, 2 root 3, 3 root 2, 2 root 3, and then it is a minus b whole square. We use this identity here, and when we multiply, cross multiply here, we will get root 2 root 3 into root 3 plus 2, that is 2 into 3 6, and 2 times this, and yeah, we can see it's like multiplied here, and then 2 root 3 into root 3, 2 3 is 6, and 2 into root 3, 2 root 3 into root 2, root 3 into root 2 is root 6, so 2 into root 6 here. And denominator, once the denominator is 6 here and it is 1, then we can we can take common from here, 6 common, then it is 5 minus 2 root 6 upon 6, 6 got cancelled, we got 5 minus 2 root 6, and here 6 root 2 6 cancelled, and we got 5 plus 6, that is 11, and hence it is same. Yeah, next one is show that x is irrational if x square equals 6. So if x square is 6, then x is going to be plus minus root 6, which is of course irrational number. So we can also give this as just a support. We can write this as non-terminating, non-repeating, that's why it is irrational number. Similarly this also, we can see this is rational part, but due to this it is becoming irrational, so it is irrational. Similarly 27 square root, again it is going to be irrational. Show that x is rational if x square is 16. So x square is plus 16 means x equals plus minus root 16, that is 4, and 4 is a natural number, and we can say plus minus 4 means they both are integers, that's why it is rational. Similarly in this case also, 1 to 4 decimal places, so it is going to be 2 decimal places, and 4 square root is 2. So again it is rational, these decimal numbers are rational numbers. And then x square equals 1, not all decimal numbers are rational number, but it is terminating, so that's why it is rational. Here again, first of all, we will denote it as mixed fraction, improper fraction, 16 by 9, and we take the square root, 16 square root is 4, and 9 square root is 3, that's why it is going to be rational. And the last question is, using the following figure, show that BD is x. Show that BD is root x. So here we can see this length from A to B. This length from A to B, it is x, and B to C, it is 1. It means if you talk about the diameter A to C completely, A to C diameter, then it is going to be x plus 1. And hence the radius is going to be the half of the diameter, that is x plus 1 divided by 2. And diameter, we can see here is one diameter is OC and another diameter is OD, OC and OD. So OC and OD we have x plus, it is x plus 1 divided by 2, and this is also x plus 1 divided by 2. Now we will calculate OB. So OB is, we can see OB is OC minus CB. Total is OC minus CB or BC. So this is 1. Total was OC is of course x plus 1 divided by 2 we have seen. So x plus 1 divided by 2 minus 1, we will simplify it. It is cross multiply 2, x plus 1 minus 2 upon 2, that is x minus 2 upon 2. So OB we got it as x minus 1 upon 2. OD we have, OB we have, and it's a right angle triangle. So by Pythagoras theorem, OD square is going to be BD square plus OB square, and we have all these values. We will simplify these all, and we can cross multiply, and we can do the simple algebra to solve, and we will get BD as root x. So that's it from the 1D. So we will discuss the next chapter in the next video. Till then, thank you so much.